for 5 minutes.
Thank you. Thank you, Chairman Lamb and Ranking Member Weber, for holding this important hearing. Thanks to all of you panelists for being here with us today. The U.S. relies on a robust cybersecurity front to keep our critical infrastructure, including delivery systems, safe. And I'm pleased that the President and his administration have made cybersecurity a priority. President Trump's national cybersecurity calls for the development of a superior cybersecurity workforce. This strategy states that, quote, a highly skilled cybersecurity workforce is a strategic national security advantage, close quote. And I agree with this assessment. Nearly 2 years ago, I had the opportunity to moderate a panel at an Arizona State University cybersecurity conference, and we focused on education and workforce in this area. The panel included cybersecurity professionals representing ASU, PayPal, McAfee, Network Command at Fort Huachuca, and the National Institute of Standards and Technology. And the main issue is raised on how, and some of you have addressed this, and the cybersecurity workforce shortage that this country is facing. The Center for Strategic and International Studies reported that the U.S. was facing a shortfall of almost 314,000 cybersecurity professionals as of January 1st of this year. And I think it's important that we work to encourage a free market, non-intrusive solution to develop a cyber workforce capable of managing not just the threats of today, but anticipate the threats of tomorrow, particularly in the energy industry. So I'm going to start with a question that I want to give each of you a shot at answering, and then I do have a couple more questions, so if you can help me out by being as concise yet as informative as possible. How do you think government can become a better partner with higher education institutions and industry to form an education pipeline that will actually meet our cybersecurity workforce needs to keep our electric grid safe? So I guess we'll start with Ms. Hamilton on this side, and then go my right to left, your left to
Great.
right.
Okay, I'll be really quick because I'm not a cyber expert, but just on education, I think you need to start much younger than that. We need to have it in all of our elementary schools too, to try to get kids interested in doing this too. So I think having public-private partnerships are important, making sure that you bring in, so maybe you'll bring in some teachers who are science teachers, bringing in, whether it's from a university or middle school to try.
And not to interrupt, but are you talking about specifically STEM or computer?
STEM, and
coding,
also just if you're interested in specifics, cyber, get kids interested in that too early.
Great, thank you.
I'm also not a cybersecurity expert, but I'm really thrilled that my 15-year-old twin girls are here in the audience hearing this, because their high school has a program that is partnered with the U.S. Naval Academy specifically on cybersecurity, and I really want them to take it. So.
Okay, so are these your daughters, you say?
Yes, yes.
Please raise your hands so we can put pressure on you publicly.
No pressure, no pressure.
Thank you. We're helping out. Mr. Torres.
So I would concur with my colleagues here. It's important to really spark that interest in STEM fields early. The other thing is I think we need to provide mentoring, because it's not just getting the workforce out there, it's getting the future teachers and getting the future professors. And this is back to a point I made earlier, which is the fact that we need to continue to get people to advance their education and be the mentors and mentor the future teachers as well as the future applications.
Thank you, and I'm sorry, I'm going to skip you, and maybe we can have a one-on-one dialogue later. So because I have to ask this other question, which intrigues me, because Mr. Torres has repeatedly talked about and several of you talked about the future grid, or what the grid looks like in the future, and it's really tough to be clairvoyant, obviously, but I'm wondering what your thoughts are on the role that microgrids might play in making the grid more resilient, and what does the microgrid of the future, what might that look like? And Mr. Torres, since you've talked about future grids, we'll start with you.
So just to make sure everybody's on the same page, a microgrid, basically a simple way to define it, there are formal definitions, is essentially a grid that has its own generation, its own wires to move the electrons, and its own loads to use those electrons, and can connect and disconnect from the larger utility grid. So I believe they do have their role. They don't need to be used everywhere. I foresee that the future grid would be some sort of a hybrid of a centralized grid base with some decentralized microgrids, especially for critical loads. We've seen that they've been very applicable where you have military installations, highly critical loads like hospitals, some key industrial areas and so on, that may have a lower reliability connection to the utility grid, and where you may have some very sensitive types of load, sensitive to perturbations and disturbances in the grid. So you really need to right fit it and right size it. It's not a ubiquitous solution.
Okay. Unfortunately, my time's expired. Thank you.